All right, so let's get started. What we want to do today is define momentum and calculate momentum. And then we're going to continue on Thursday with solving collision problems and applying the conservation of momentum. All right, so let's go ahead and define momentum. Well, momentum can be defined as mass in motion. It's simple, but all we're saying is if an object is moving and it has mass, then it has momentum. Momentum is the product of an object's mass and its velocity. Okay? So mathematically, momentum is mass multiplied by velocity. Remember, velocity is the physical quantity that tells us how fast an object is changing its position or displacement. Okay? Momentum is measured in kilogram meters per second. So that little dot, that just tells us that the two quantities are being multiplied. Okay? So let's jump right in. I'm going to give you a minute. If you don't have your calculators next to you, go and get them because we're going to be using them quite a bit this morning. So go ahead and get your calculators. Just type in the chat box, got it, when you have your calculator in hand. All right, great. First problem. Calculate the momentum of a 75 kilogram speed skater moving forward at 16 meters per second. So what we want to do first, we want to write down our formula. Momentum is equal to mass multiplied by velocity. Then we want to go ahead and underline the quantities that we see mentioned in the problem. So momentum, denoted by the letter P, and we don't know that. We're trying to find it. Then 75 kilograms is our mass. Because I didn't feel like fixing my hair this morning, Alexandra. Is that okay? 16 meters per second is our velocity. So we go ahead and multiply those. 75 multiplied by 16. Yep. Siobhan said we get 1,200 kilograms. Kilogram meters per second is how we say that, okay? So here it is, much neater than I can write it. Okay. Easy peasy. You are typing in the wrong values. Do it again, Kentia. Strange. Use your phone. We're going to do another one. You have a scientific notation or engineering notation. Either way, you should still be able to interpret that. All right, example 2. Calculate the momentum of a seated 48.5 kilogram passenger on a train that is stopped. What's zero? How do you know? Ah, keywords like stopped or stationary or at rest, they tell us that the speed of that object is 0 meters per second. Will it? Let's pull out our formula. Momentum is mass times velocity. The mass is 48.5 kilograms. That's not changing. Matter cannot be created or destroyed. But momentum is mass in motion. So if the mass is not in motion, aka the velocity is 0, then the momentum is also 0. Okay? Exactly. Job. What about this one? Calculate the velocity of a 0.8 kilogram kitten with a momentum of 5 kilogram meters per second forward. What do we have to do first? Can you guys just humor me and walk me through the steps? I'm going to give you all some harder problems in a minute. What do we do first? Yes. Transpose the formula. So I'm going to pick up my triangle or whatever shape this is. And I want to find velocity. So velocity is momentum over mass. And I get, yes, 6.5 meters per second. Okay. Good job. All right, let's kick it up a notch. All right. Really rudely. Now you come in this room with that name. So y'all, I can't take y'all seriously. All right. Answer my question, please. Thank you very much. It's D, okay? Calculate the momentum for A, B, C, and D as the largest value, okay? What about this one? What's my answer? Thank you. And you are correct. Okay. All right, next one. You should be answering these in a minute or less. I want a couple more answers. Whiny, Tyreek, Chanel, Brianna. Okay, I see Brianna answer. Right, Brianna, why'd you pick B? Brianna? I think I could hear you trying to talk. Somebody tell me why'd you pick B? Oh, I see you there. Okay, you typed. Which means that its velocity is what? Awesome. All right. So the answer is B. All right. Remember, you have to multiply both the mass and the velocity. And just take the mass by itself if the velocity is 0. This is multiplication. Anything multiplied by 0 is 0. Good. All right. Exactly. Since the ball is stationary, the velocity is 0 for the ball. The velocity of the soccer player, however, is 4 meters per second. And his mass is 100. So we multiply 100 by 4 to get his momentum, 400 kilogram meters per second. Okay? What about this one? Awesome. Let's check it out. Okay, so we know both masses and both velocities. Okay, remember the momentum is the product of their mass and velocity. It doesn't matter if they're traveling at constant speed. All right. So when we look at both of the products, 4 times 10,000 is 40,000, and 40 times 1,000 is also 40,000. So they both have the same momentum because the product of their mass and velocity is the same. Okay? You see that now? Mass times velocity. Awesome. Okay? As long as they have speed, they're gonna have momentum. As long as it's moving, it has momentum. What about this one?
You all too quick. Why you all so quick?
Don't worry about how quick they get it. Just get it right. It could be quick and wrong.
I even had a chance.
Focus. Not a race. Just get it right. Read the question carefully. What am I gonna see? I need to see what you're saying. Don't you worry about everybody else. You put your answer. And if you've done the question carefully, don't worry about everybody else. We'll all know in short order. Either way, we'll learn. All right. Um, Candace. I think that's Candace. Tell me why you picked A. All right, clear up that second part for me. When you use numbers, tell me what numbers, which quantity you're talking about. All right. Anybody else want to elaborate? Walk me through your calculations. What did you calculate first? And then you could talk.
Okay, so first I calculated the first momentum. So I times 2000 times 10, and then I calculated it. I calculated the second one, so that was 2000 times 50. And then my answer for the second one was C. But then I say what was the increase in momentum? So I'm guessing we're supposed to subtract the two values, so then it'd be 8.
Awesome. Couldn't have said it better. Okay. So that little word, increase, that tells you you're finding the change in momentum. So you should find the initial momentum and the final momentum, and then find the difference between them. Change in momentum, the momentum 2 minus momentum 1. So we would get 2000 times 15. That's my second momentum. Subtract 2000 times 10. And when I work that out, I'm going to get 10,000. If you pick C, what you did was yes, they asked for the new momentum, then your answer would be C. But they asked, what will the increase in momentum be if we increase its speed to 15? So the difference between the old momentum and the new momentum is 10,000 kilogram meters per second. Make sense? Awesome. Yeah, I'm eating yogurt. I'm finished now. Pay attention.